because this is our review. So Carla Soto, which one do you want?
Which one was the one that you said that has like to make a little chart to make it easier?
I'm not sure exactly, but they're probably in the looping one here.
Okay, then 1.0.
This one?
Yeah.
Okay. What is the first thing that you do before defining or writing any code? And I will count that as right, because that's what we have done, actually. She put your name on it, and that is a right thing to do, yes. Now, it is, now we haven't gotten to the algorithms yet. When I've taught this class in the past, I jump right into algorithms, but in this class, for whatever reason, I've been postponing it till next week. Okay? But before writing code, you should decide on how your code is supposed to work, and you are supposed to write an algorithm. Now, for these easier programming problems, sometimes you can just think of the algorithm in your head, and that's what we've been doing so far. We've kind of thought of the algorithm in our head. We haven't formally written it down. But next week is when we start studying algorithms, and we'll start formally writing these down in algorithmic style. Okay? And that'll be the first thing that we always do. Because as you get better and better at programming, the algorithms become the hardest part. Writing the code is cinchy. If you have a good algorithm, taking that algorithm and making it into code, simplest thing you could do. In fact, that's what computer science is. It's the study of algorithms. It's not how to program. Computer science is how to write an algorithm so that somebody can program it. It's the study of algorithms. That's how Google has made all its money. It's on their searching algorithm. And now they have a whole bunch of other algorithms, but that's how they first made their money, was having a great search algorithm. Okay? And that's just the steps you do, like a flowchart. But you got your point, so good job, Carla. That was smart to say, yes, you should always write your name on the top of your programs. So, all right. Stephen? All right, so which one?
Writing code for 3.
Right in the middle. All right. Now, it's just a little test program. It's really not that bad. If you entered 1, 2, and 3 when you run this program, what will be your output? So think about... Yeah, so notice that the first input's right here. So I named my keyboard, my scanner object. I didn't name him keyboard. I named him input. So remember that input, that scanner object can call next double. So you entered in 1, 2, and then 3.
I'll do 6. Output is 1 plus number 2 plus number 3. Oh, sorry, 2.
Good, yes. I'm like, I know you know this one. Yeah. So, you know, it prints out the average, and it'd be 1 plus 2 plus 3 divided by 3, and it would be 2. So good job. Yes. And that's a good test question, because you have to be able to read that code, understand what it does. So, okay. So good job. So good job. And I'll pick the next person as I write down your points. So you got your points. Good. That was 3. Which one do you want? Oh. Oh. I thought it was you. Okay. Which one would you like? Any of them. You can pick a 1-pointer. Okay. You have just as good a chance of getting this right as everyone else. What should you always do in your code that will not make it readable but has no effect on your code and does not affect it when you compile it? That is good, yes. We will definitely take that as a good answer. Okay, yes. Because it doesn't affect your code, it doesn't affect how you compile it, but it does make it more readable. Okay. And then the other answer would be to write comments. Okay, comments, but she said write indentation, which is excellent. So comments make it more readable too. All right, good job, Ariella. Okay, Seth is... Nobody Seth? Okay. Who I thought was Seth is not Seth. Okay. All right, Angelica. Up at the front, right? Okay. Cool. All right, which one would you like? Okay, cool. All right, suppose we make a scanner object. We've seen that code before. What method do you use to read in an int value? And you actually got some choices here. What do you think? No. Anyone else want to take this one for half the points? What do you think?
Isn't it A?
Yes, it is A, next int. Okay, good. Yay. Yeah. Next int. It's next int, next double, next line, next. Those are the ones we use all the time. And remember, I don't demand that you memorize things, but you should start to remember that guy. Okay? You'll start to remember him just because you use him all the time in Java. Well, it depends.
So they always start with next?
A lot of them. Actually, all of them. Is Johnson? Oh, yes. Okay. All right. Which one would you like? Okay. All right. So we have this loop, and it looks like this, and I ask you, how many times is that going to print welcome to Java? This is a good test question we always ask. What do you think? What did he say, B? Did he say B?
He said B.
Oh, okay. No. And how many guys do you guys just tell me? Yeah, 10. Because it's going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But because it started at 0, it does actually iterate 10 times. And a lot of times we have our loops like that. Remember, it starts at 0, goes to less than a number, you increment it by 1, it'll always happen that many number of times. Okay? All right. Cool. We'll get things moving here. Maybe I could pick while I'm doing my explanation. Okay, Alex. Okay, Alex, which one would you like? Ah, very good. We got a risk taker. All right. How many times is the print line statement executed? Now, this is a dual for loop, and I said, hey, we're not going to test you on dual for loops, but this is a 5-pointer, so that's why I got a dual for loop. Dual for loop means a loop inside of a loop. And you can do cool things with dual for loops. But you have to remember with dual for loop, and I know we haven't studied them in here, so I'll give you a little bit of a hint. The inner for loop finishes for every one time the outer for loop happens. So the outer for loop, for every time the outer for loop executes, the inner for loop completes itself completely. Okay? Oh, and this one is hard because I put the inner for loop is dependent on the outer for loop with I. Let's see, it is odd. And this one you really do need to write out that table. Even I would have to write out the table to figure this one out. You want to take a guess, or do you want to try to figure it out? Let's see. It'd be 0. No. It is 45. Now let me show you how it's 45. Were you going to say 45? Oh.
I was looking at my hand, I couldn't figure it out. I was like, oh no, wait.
Here, I'll start it out, and we don't want to spend like an immense amount of time on this guy, but let me show you how you would figure this one out. Okay. So you definitely have to kind of write this down usually. Okay. And this is when tables come in really handy. Okay. So in our first loop, we have I. And I starts out at 0. Okay, 0 is less than 10, we jump into the second loop. Now when you jump into the second loop, you start a new table because he's a new for loop. Okay? And in the second loop, we have J, and we have I. And J starts out at 0, and I comes in as 0. So then you check, is 0 less than 0? False. It leaves, but it goes back up to the first for loop. The first for loop finishes itself by putting the I++. Okay? Now we're on the second loop for the first for loop. It'll come down to this for loop, and it starts J off at 0 again. Every time you start the second for loop, he starts brand new. And now when you go to the second for loop, I is 1. So is 0 less than 1? Yes. Let's hope that is, right? And so that will be one system out print line. It'll execute for 0 and 1. It'll execute. So we'll just put an X here for that. It did the print line. Okay. It would print out I times 0, which is 0. It would print out 0. Okay. And then it would increment J. And we go down to the second loop, and 1 is not less than 1. So then we're done with that inner for loop. So 1's not less than 1. Okay, so we're done. But we're not done with the outer for loop. We go over here and we increment I. Okay, 2 is still less than 10. We go to the inner for loop. J equals 0. I is 2 now. How many times will that loop execute now? Yeah, 2 times. It'll happen when he's 0 and when he's 1. Okay? So we could write it all the way out. You could write it out. So I stays the same in there. And J is increased by 1. So you can see that he does execute twice. You see? I just did it kind of fast, but all right. But we're done with that for loop, but this for loop we're not done yet. We still have to execute it a few more times. So he becomes a 3, and when we get to the inner for loop, now I is 3, and how many times will we execute this inner for loop now?
Right.
3 times. Hey, you can start to see a pattern. This was the first, second, third. And how many times do we execute the last, or the outer for loop? 10 times.
10 times.
Yeah, from 0 to 10. So 1, 2, 3, 4, 5. And if you add up all these numbers, what are you going to get? 45. This will happen 7 times. I don't even want to write all these down. And then 8, and then 9. Okay? All right. Does that make sense? And that was a harder one. And just note that I wouldn't have that on your test, but that's when you really need to know how to make these tables. And just the trick, I guess, with these is that that inner for loop is brand new every time you get to it. It is called a nested loop. They're either called inner loops or nested loops. That second for loop is nested inside of the first for loop. They call them inner and outer loops. And when we're sorting things, you can use do for loops like this. You use do for loops to make like tables. They're very inefficient, okay, and they could lead to your program running really long periods of time. Because for every time that first for loop happens, that second for loop completes itself, they can lead to a lot of things. If you have more than 2 and you have 3, it would be really, really inefficient. Okay? We still use them, but just note that when you see 2 for loops, you just think, oh, that's probably going to take a really long time to execute usually. Okay? The more inefficient algorithms, sorting algorithms, use 2 for loops like this. Okay? Cool. But that was our 5-pointer. All right. Cool. It's good to be brave and pick a 5-pointer, actually. Okay. Jessica. Okay, cool. All right, so we got some code here, and actually this is a book question. Okay, so this one is from your textbook. Which statement below is true, and only one of them is true? And you can read them. Count less than 100 is always true at point A. Count less than 100 is always true at point B. Count less than 100 is always false at point B, or count less than 100 is always true at point C. So you got 1 in 4 chance of getting this right? Actually, you can eliminate some of them, then try to pick your best choice. What do you think? I was going to get my little timer. All right, so what do you think, Jessica? Does anyone else want to try to answer? Or do you want to at least try to just A? It is true at A. Yes. So either you really knew it or you got lucky. But it is at A. Now note why this is always true at point A. If this Boolean statement is ever true, we know that count has to be less than 100. So we know that we're never going to get here if count was bigger than 100. So we know it has to be true. Because if it was ever false, we would skip down here to point C.
Yep, that's how I found my answer.
Good. And then at point B here, how do we know it's not true at point B? Because when it's going to be false up here, or when it's true the last time around, let's say when it's 99. It's still less than 100 here. It becomes 100 right here. So at point B, he will be greater than 100. And then when it comes back up for that Boolean check is when it'll be false. When count is equal to 100 is when that loop will stop executing. All right. But that's a good question, you know. And because I've seen that question over and over, I think it's, you know, pretty easy to tell, but manual. All right. So we have some branching statements. And I just ask you what the output is. And that is true. Good. Okay. So remember inside these kind of coding problems, you would just plug in the number. You just say, hey, is 50 greater than or equal to 100? False. Is 50 less than 40? False. So then it has the else part just right. Okay? Good job. Just right. All right. Gerardo is... Which one would you like?
dollar knowledge.
Okay, that sounds good. 1 byte has how many bits? Yes, good. 8 bits. Good. And that's just some knowledge you should just have. In today's world, you should just know that. Matthew. Which one would you like?
Oh, I was a little bit more
Good. Now this one looks like a lot, but it's different answers, okay? Everyone always wigs out when they see this slide. Now this is a book question, actually. So suppose we write the code to display can't get a driver's license if your age is less than 16, and you can get a driver's license if your age is greater than or equal to 16. Which of these following code is correct? Which of them would execute that? Okay, is that your final answer? Does anyone else have an answer? What do you think? Yeah. No. Actually, B's right, but what else? A is right. Oh, they're all right. Oh, that's why it's a 5-pointer. That's so tricky. Actually, they're all right. So they all do the same thing. Actually, they all do the same thing.
But on A, you don't have an else statement, right?
That's okay, though. It does that logic, though. We have greater than or equal to right here. And you don't have to have an else.
So then, would that be running twice? It will run the first code?
Oh, yeah, so it would do both Boolean checks. It would do both Boolean checks. So if they were 15, it would check it here and it would check it here, but it would only run this line of code because it would only be true up here. It would be more inefficient. What's the most efficient way to write your code? B. That would be the most efficient way because you're only doing one Boolean check. It's the least amount of lines of code. Yeah, and it's very efficient. Okay. Yeah, that one is a harder question. Yeah, it's not it's right. You're supposed to say all of that. Wait, is Joseph here? Who's Joseph? Oh, okay, you're Joseph. Okay, Joseph. What is X after the following code executes? Remember, 5-pointers are 5-pointers for a reason. Good guess, but not right. Does anyone else have an answer? What do you think? No. It would be a syntax error because you can't have switches with doubles. I guess that would be a trick too, right? I don't know. All right. No, you only can use switch statements with characters and integers. And then with Java 7, you can use switch statements with strings. So actually, all programming languages are like this. You usually cannot use a switch statement with a double. You have to use it with characters or integers. And it's because, doubles are stored incorrectly in your computer. Well, I mean, they're stored correctly, but there can be those off by 1 errors, remember, in your computer, or those small errors. And so they don't let you have switch statements with doubles because they can lead to programming errors because You can never correctly store a double or check equality of a double. Yeah. So yeah, Eclipse would have warned you and red underlined that and said, no, you can't do that. So yeah, you can't switch on a value of type double. But if you could switch on a value of type double, it would have been that last one. X would have equaled 3, right? All right, Yi, I saw him up All right, which of the following is the correct expression that evaluates to true if the number x is between 1 and 100 or the number is negative? So how would we write it in Java? Not just in math, but how would we write it in Java? It is not D. He said D as in dog, right? Which one would it be, Stephen? Which one would it be? It is B. Okay, good. Okay, so note how this works. Your order of operations, it would do this part first. Oops. It would check x less than 100 and x is greater than 1. Okay, so it checks to see if this is true first. And then this is the or x is less than 0. Less than 0 means it's negative. Okay, so good job. That one is right. Who's Edward? Edward's not here? Okay, I didn't think so. Let's remove him. And Bishop. All right, Bishop, which one would you like?
A little bit Boolean. 3.
Boolean. All right, so here's a truth table. We went over truth tables in here, right? And so it's expressing a logical operation. So what goes in the place of the question mark? So this is our input 1 or our first Boolean statement, and then that logical expression, and our second Boolean statement. What would go in the place of that question mark? Our logical, the and, the or, the not, right? The and operator, good. Because the only time and is true, this is our output, the only time and is true when both A and B are true. Otherwise, it's false. The first Boolean expression has to be true, the second Boolean expression has to be true when you combine them with the and operator. Okay, good job. And that was 3 points. Right, Bishop, that was 3? That was 3, okay. Oh, Sochi. I like so chill. Just kidding. Sochi. I like that. Okay, cool. So what is the result of 45, the int 45 divided by the int 4? It's int math, remember. Okay, what do you think? I know she got this. She got it. What do you think? It is B. Good. And the reason it's B is because we're doing int math. Remember that when we do int math, it drops the decimal place on the floor. Okay, so remember that in your test. If it said 45.0, divided by 4, it would be C. But because it's 45 divided by 4, it's B, because it's int math. Okay, so remember that. That's a good question to ask people. A double divided by an integer is a double. An integer divided by a double is a double. It always takes the bigger. The answer will always be the bigger of the operators. Okay, but an int divided by an int gives you an int, and it gives you 11. Gives you the wrong answer. Unless you want to concatenate the decimal places, then it gives you the right answer. All right, Gladys. And I'll start to remember your names better now. Okay, Gladys, which one would you like? Good. Suppose x equals 10 and y equals 10. And then we have a Boolean expression. What is x after evaluating the Boolean expression? Actually, this is a book question. No. What would x be, Bishop?
Okay.
Yeah, it's 9. Okay, so after the Boolean expression, it has to decrement x, and so it would be 9. So it decrements it, meaning it subtracts 1 from it. That's the minus minus, that's the subtraction. And just so you know, too, what would our answer be to the Boolean expression, true or false?
True. No, it's false.
False. And we can see that it'll be false just because 10 is not greater than 10, and so this would be false, so it wouldn't even check this part. Oh, actually, yes. Actually, it is 10. You're right. Dude, I didn't even realize that. Yes. Good job, Gladys. Yay. You are right.
You're on your way.
You are very smart. Good. And that's why it was a 4-pointer. This was a 4-pointer, right? Yeah. Okay, this is how it works. Glad we did this, yes. So when you plug in 10, 10 is not greater than 10. It short circuits, so it says, hey, this is false. I'm not even going to bother checking the rest. And so it actually never gets to this code. And so x does stay 10. Very good, Gladys.
Has to be true in order to do the comparison.
Yeah, and if it's true, then it'll check the rest of the AND statement. But if it's false, it's called short-circuiting your AND statement, or your logic statement. And it'll say, oh, false, I'm not going to check the rest, and it'll leave. It makes it more efficient, and then you can do things like this. You only want to decrement x if y is greater than 10, maybe. Okay? Very good. Yay. I'm sorry you said it was wrong. Good job, Gladys. You're like, what? All right. Jason. All right, which one would you like, Jason? All right. The equal comparison operator in Java is written as... Yes, equal equals. Very good. That one's pretty easy, hopefully, for everyone. Good job, Jason. And then Ty is... Which one would you like? All right. The blank method immediately terminates our program. Yes, it is C, system.exit. Very good. That's not the best way to terminate your program, but it does work. Okay, Jose is... Ah, very nice. There's a 5-pointer left. Blank is a software that interprets our Java bytecode. What is it? What do you say? Oh, no. It is a sort of compiler, but that's not what it's called. It's not considered a direct compiler. Let's see. Your name was Joseph. You wanted to answer. What do you think it is? It is Java Virtual Machine. Very good, Joseph. Yes. So remember that the way that Java compiles your code is it goes through what's called a compiler at first, and it compiles it to bytecode. And then that bytecode file is your executable, and it has to be given to the JVM. And the JVM is sort of a compiler. That's why I said it was sort of a compiler. But it's not taking source code and compiling it. It's just taking that bytecode and making it into the correct machine language. So there's different JVMs or Java Virtual Machine for your operating system. Okay. So you have to have the JVM in order to execute bytecode. All right. Very good. All right, Justin. Sorry, I didn't, my brain. Okay, Justin, which one would you like? Okay. Do the following two statements in 1 and 2 result in the same value in sum? What do you think? Yes, good. And this just shows like the difference between the pre-increment and post-increment operator. But in this case, it doesn't really matter because they always end up at the, they always execute this part at the end of the loop. So it didn't matter if it was pre-increment or post-increment. Okay.
What would be the difference?
If it was like in an equation, like if I had, oh, and I didn't open up my Eclipse. But if I had some code, maybe I'll just write it here real quick, that said like plus plus right here. And then I had some code down here that said plus plus in front of him. This would make a different value for sum. And the reason being is in this code, I would be 0, and it stays 0 when you first add it to sum, and then it makes it 1. Where in this code, the first time around when I is 0, it makes it 1 first and then adds it to sum. So that's the only, time that pre and post increment really matters when they're in an equation or inside of an array index. Okay. But good job. Good job, Dustin. Let's see, how many points was that? 4. Okay. That was a good one. Yes. Oh, yes, I know. Okay. All right. Which one would you like? Okay. Cool. So we have a loop, and we're writing some stuff to the screen. Take a look at that loop, and you can use your pen and paper if you need to. Think about how many times it's executing and what it's doing, and then tell me what the output is. What do you think? Oh, B. No, what do you think, Sochi? It is D. Very good. Yes. And the reason being is because we put the I++ in the loop. Now, I always advise don't ever do this. We did this for this test question, but you should never change the value of I in your for loop. It's very rare that you would ever really want to change the value of I in your for loop if he's controlling the loop. But because we did, it double times him. So the first time around it prints 1, changes him to a 2, changes him to a 3, prints 3. Changes him to a 4, changes him to a 5, prints 5. 6, 7, prints the 7. 8, 9, prints the 9. 10, 11, and then it's false. So it does print out the numbers 1, 3, 5, 7, 9. Okay, does that make sense to everybody? Good steal. All right. And then who do you think is going to be last? Oh, it's Eric. All right.
Some good Java knowledge for a
All right. Blank consists of a set of separate programs for developing and testing your Java programs, each of which is invoked from a command line. And we had to download this at the beginning, like the first week of class.
C.
Yes, JDK. Very good. Yes. Our Java Development Kit. That's what that stands for. All programming languages have a development kit that they give to developers so that they can start building things. Our Java Development Kit has all of this, but we pretty much just use our compiler a lot. Integrated Development Environment. IDE is like Eclipse. Eclipse is an IDE. NetBeans is an IDE. Your notebook. Okay. So there's a couple of questions, but I'll just leave you guys those ones to study. Because I am going to post these PowerPoints right after class as PDFs in our lectures, so then you can go home and look at them. These are good sample test questions. Just remember that I won't have the 5-pointers on the test. Okay? None of the 5-pointers get to the test. Okay? They're up here just for fun. Oh, wait, I need to pick a name. So control, oops. So I have to re-put your names back in that little name picker thing. Oh, it's gone. Okay. Cool. And we'll do the second PowerPoint. Hopefully we're not burned out. You get a brand new PowerPoint. Wait, was it? Oh, Edward wasn't here. I already marked him down and he wasn't here. All right. Now Gerardo is here. Okay. Hey, we just discussed this. Oh, lucky you. You better get it right.
Java development.
Yes, Java Development Kit. Good. If you got it wrong, I'd have to throw the pen at you. That was 3 points? That was a good one. All right. What is the result of the following equation when inserted in a Java program? Make sure you know what data types we're working with here. Oh, we said 2? And is he correct, guys? Yes, because it is int math. Okay, so it does give you the result of 2. Good job. Got to remember our int math. All right.
variable for what?
All right. Now this is a book question. Actually, this might be from our old book, but it's still a good question. What's the output for the following program lines when embedded in your correct program? It declares all of your variables of type char. So they are char variables. You have char variable A, B, and C. what would be your output? Does anyone know what the output would be? Hey, wait, who said that up at the front? BC. Yes, that is right. And do you guys see why? So the character variable A equals the value B. And the variable B equals the value C. So you can think of this as a cup with the letter B inside of it. This is a cup with the letter C inside of it. And then this is a cup called letter, this is the variable C. And what does he equal? The variable A, and the variable A is B. So it's like putting the B into the C cup, like copying it, like photocopying it to the C cup. So then it'll print out B for A. Inside of the A cup's the letter B. In the B variable, we have the letter C. In the C variable, we have the letter B. And then it just prints the letter C. Okay. All right, so good. Okay. Okay, change. Variables, okay, for 5. What's the output to the following program lines when embedded in your correctly working program? And here we're dealing with strings. So what do you think our output would be? What do you think? No? Does anyone else want to try to answer? Yes? Yes. And would there be any spaces in there? No. Okay, good. And the reason being is when we use the plus operator here, remember that's called a concatenation operator, and it just glues them all together with no white space. So it is just gluing them together. All right, good. How many points was that one? It was 3. All right. Just wanted to write down Matthew's points first. Okay, what output would be produced by the following code when embedded in your complete program? What do you think, Manuel? I know you got this one.
I don't know much about cooking. Chocolate ice cream?
Okay. Does anyone else want to try to answer? Justin, what do you think? Yes, it does print both of them. Now it prints chocolate ice cream, and then it comes and it looks for the break statement. There's no break, so it keeps. This is how switch statements work. If there's no break, it'll just keep going down. It ignores the other case thing and just keeps executing your code, and it will print onion ice cream, and then it hits the break. So it will print both of those, and then you'll get chocolate onion ice cream. Yes, they do have onion ice cream at, not onion ice cream, garlic ice cream at the stands on the way to San Jose. Oh shoot, we need to pick somebody. Steven. Which one would you like, Steven?
Dollar basis for
Okay, name the 3 types of errors that can appear in your program.
Syntax error, runtime error,
So you got it, syntax error, runtime error. And then the hardest one,
it's logic error.
yes, the logic error. Yay! So good job. So, so good job. It's all right, on, okay. Which one of these variable names would cause a compiler error in Java? I'm not really sure why I made this a 5-pointer, but that's okay. Good, maybe that's why I put it, you did have to know both of those. Good job, Joseph. Yeah, the long and the short, because they're both keywords. They're both data types. Good, good, Joseph. So 5 easy points. All right. And all right. In college algebra, we see expressions like 15 less than x less than 20. And this means that x lies between 15 and 20. And you could tell it to me, or you could write it down, but give the correct Java Boolean expression that does this. So what do you think, Johnson?
15 less than x and symbol, and x is less than 20.
Yes. Good. We said remember that we had to break them up into 2 Boolean statements and connect them with the and, how Johnson said. So it'd be 15 less than x, connected with the and symbol, and then x less than 20. And the parentheses actually are optional, but a lot of times we write them in for clarity. Okay? So, good job. All right. What would you like? And Johnson, was that a 5-pointer or a 4-pointer? Was it a 3-pointer? Okay. Sorry. Sorry, Jessica. Go ahead. Which one? Like this one? Okay. Java knowledge, 5 points. We have some code, and I ask you, what is our output? So what is sum at the end of this? All right, so what do you think? Does anyone else want to try to answer this one? Sochi, what do you think? No? Gladys, what do you think? Yes, it is an infinite loop. Good job, Gladys. And it's because we have that or statement. Actually, this is the same one as our lab. Do you remember we did our lab? No, it's a good job. So she just recognized that it had an or statement, so this one's always true. You see how number starts out greater than or equal to 0, and then it just keeps increasing, so you know, hey, that's always going to be true, and we're connecting with an or. Uh-oh, we have an endless loop. We have an infinite loop, so it will never get to print out sum. Or you can say sum is infinite, but it never actually prints out sum. All right, and Ty. What do you think, Ty? Which one would you like? For 4, you said? Right? Okay. So we have some output to the following program. So this is a correct embedded in a complete program. What do you think will be our output? So what do you think, Ty? If you want to sit down, you can move it. Okay. So what do you think, Ty? What do you say?
I'm gonna let someone answer it.
Oh. What do you think? It does. It's an endless loop again, actually. Okay. So, it starts out at 2. And then the only way we can get out of this loop is if the number is not less than 10. So it had to be greater than 10, either 10 or above would make this false. Okay. And if the number is equal to 3, then we exit the loop. But we start out at 2. So we know we're never going to exit this loop. Because we're just subtracting from number, we're not increasing number. So we're never going to make this false. So he'll start at 2, and then 1, 0, and he'll just keep going around and around. Infinite loop. All right, so good job. How many points was that one? It was 3? Okay. I just want to make sure I write down points right. All right. So Angelica. For 2? Oh, 3. Okay. How many bits is an integer? Bits. What do you think? You can take a guess. Just guess. What do you think? No. There's 8 bits in a byte.
They're like 2,900.
That's how big of an integer you can store in there. That's how big the number you can. But the actual little ones and zeros in the computer, like the RAM locations, 4 bytes, it would be 32 bits. Okay, at the last column I was running out of questions, but your integers typically are 4 bytes in a lot of programming languages, not just Java. A lot of times your programming language will allocate 4 bytes of memory for an integer. And for every byte there's 8 bits, so it would be 32 bits. Okay. So that one was a tougher one. All right, Gladys. All right, so we got, oop, dang it. Somehow I went back. Okay, so we got this loop going on. What is the output to the following code when embedded in a complete program? And it looks like the other one, actually.
Do you want to just, what's the first one going to be? Or?
Well, what's going to be our output?
It's going to be 6, and then it's going to be 0. It's going to print out 6, and then hash line.
Good.
So then 5 is greater than 0, 5, and then subtract 1 from 4. You want me to go?
Yes.
Okay. 4 is greater than 0, so 4, 3, 3.
Now when it's 3, what happens?
But it's a break. So then you end up.
Right. Good. So it would print 6, 5, 4, but when it gets to 3, it breaks out of our loop, and then it would print end of loop. So good job, Gladys. Oh. Yeah, I just put random pictures in there. All right. See, how many points was Gladys's? It was 3, right? All right, Seth. Which one would you like? Wait, is Seth not here? Wait, who's Seth? Okay, we need to cut that out of the video. Just kidding. Did I mark that he wasn't here before? No. Okay. Now I did. All right. So chill. What would you like, Sochi?
Java Basics.
Okay, Java Basics for 2 points. And we have a fill in the blank. A blank is a set of instructions that tells the basic strategy for solving a problem. Starts with an A. Yes, algorithm. Very good. And remember, we'll start focusing on algorithms next week, and yeah. It'll be our main focus for a while. So good job, Sophie. And Justin. Which one would you like, Justin? All right. What would be the output to the following code? And actually, I remember having this one before. What is it? Yes. And why? Yes, very good. Okay, so here, remember that I forgot I had 2 of the same slides in here. But that's good, because this is important that we know this. Yeah, you can't use double in a switch statement. Okay, very important. So good job, Justin. That was easy points. Jason is here. Jason, which one would you like? Okay, going loopy for 5. Our last 5-pointer. All right, so we have some code from a temperature conversion program. And there's an error in the code. And what do you think our error is? And actually, it is a logic error, so see if you can find it. What do you think it is? All right, I saw your hand up there. What do you think it is? Very good, yes. Now note that when you say next int, it will take in that integer from the keyboard and put that int into degrees F. But because an int can fit into a double, but that would be the wrong output then, because we're going to get the wrong number. Okay, so good job. Let's see, that was Mariella, right? And you were afraid you weren't going to get any. All right. Oops, we forgot to roll. We got to roll. second, Alex. And I know Alex. Okay, cool. Who invented Java? This is a good test question I always have. Because we're studying Java, we should know who's responsible for inventing it. Actually, I saw Steven's hand. Steven, who is it? It is Gosling. Do you remember his first name?
It's Ryan
Yeah, James Gosling. Very good. Good. Good, Steven. Good memory.
Almost correct, though.
Actually, you got a lot of points, Steven. Good job. Yeah, James Gosling. We should recognize and know him. Okay. Now, he didn't make it all by himself. He had a group of engineers working underneath him, okay, when he worked at Sun Microsystems. But he is given the credit, and if you look up inventor of Java, he is given, the credit for inventing it. All right, Mariella. What would you like? Okay. So, what would be our output? That's a good one. So, what do you think? 7. Gladys, what do you think?
17.
Yes. Well, actually, no. Almost right. And it is.
6 and 7. Oh my God.
No, almost right though. Again. And let's see, it's not Jason in the front. What's your name again? Yeah.
6'8".
It is 6'8". Now look at it. It prints out 6 first, and this is the post increment operator, so it uses the number first, then adds 1. So it does print 6. It changes it to 7. Now this is the post increment operator, so it adds 1 first, then uses it, so it changes it to 8, and then prints it. And I know that looks a little odd, but that's showing we know how pre and post increment operators work. Is that it prints 6 and then 8. Normally in a program we wouldn't write something slightly, so awkward looking, but oh, it's Matthew in the front. So Carla. The what? All right. So Carla, which one would you like? That's okay. That's okay. I've done that before too. You're okay. Cool. All right, so this one, I guess you could kind of tell me how to write it. But you have to remember all your syntax. Or you can write it and then come show me. But it's to write the mathematical equation in programming code. Are you going to write it down and then show me, or just tell me? Oh, you are? Are you writing it? Okay. Cool. So you'll have some of these. On the test, I'll have a multiple choice, but you'll have some of these. You should be able to convert these guys. Awesome. So it'd be, she has parenthesis 2 times x plus y parenthesis, division symbol 3 times y times y. Yeah, we'll come again. And that's correct. Yay. Good job, Carla. Yes, perfect. And she had it written just like this. Now, she had an extra set of parentheses on the outside, but that's okay because extra parentheses aren't going to hurt you. Okay? So, good job. You just had to remember to change actually write the multiplication symbols. And you could use math.pow like we said, or y times y is the same thing. So, math.pow, you would put math.pow parenthesis y comma 2.
Is there actually a character for using power?
You would have to have y as a variable. Yeah, you'd have to have y as a variable name. So in this one, we're just assuming y and x are variable names, which aren't the best variable names, but yeah. A lot of times in these questions, we use y and x, but in real life, we would use better variable names. But go ahead, Stephen.
Or if you want to do power 3 instead of do y times y times y.
Mhm. Or you could do math.pow y comma 3. Because we have the math.pow 2, because when we want to do power of 5, you don't want to multiply those out. All right. But good job. And ye. I want to make sure I got Carla's points too. Which loop has to happen at least one time? No. I saw, was it Justin? No. What's your name?
Eric.
Eric, yes.
Is it do while?
It is a do while. Good job, Eric. It's our do while loop. Has to happen at least one time. Because remember, the Boolean check is at the end of the do while, so it has to happen at least once. Okay, let me get Eric's point. And then Matthew in the front. You said 2, right? Okay. Sorry, sometimes it's hard to hear with the air conditioning. All right. Determine the value, true or false, of this Boolean expression. And it is the entire Boolean expression. We gave some values for count and limit. So remember just to plug in your variables. It is false. Very good. All right. So just plug in the number. You just, oops, dang it. Which one was that? Okay, I knew that. So you just plug in your numbers. So you put 5 in here. 5 less than 10? True. Do you even care about this? No. Why don't I care about this? Because it's true or something else, but it's going to be true. Okay. Then you come over on this side, because this is an AND operator. Plug in the number. 5 greater than 0? True. True and true is true. Now, why did he say false? That little exclamation at the point turns it to false. It turns your false to true and your true to false. So good job. Good job, Matthew. And last but not least, we have Eric. And Eric, which one would you like? Actually, we could go on the other PowerPoint if you want something more than 1 point. Do you care? Or do you want the 1-pointers?
Next slide.
Like this one?
Are we going back or forward?
Either way, I was going to say if you want something more than 1 point.
Oh, yeah, yeah.
Okay. You can pick one of these guys.
Another cup.
Okay, I'll get 2. Okay, the expression 4 plus 20 divided by 3 minus 1 times 2 is evaluated to, so remember your order of operations in here. Okay, I know where it is. I know you got this, Eric. D as in dog?
Yes.
No. What was it? It is 24. Good job, Gerardo. So it's, when you're doing your order of operations, parentheses first, PEMDAS. So 3 minus 1 is 2. Then it's multiplication division left to right. So 20 divided by 2 is 10. 10 times 2 is 20, and then you do the plus 4. So it does actually end up being 24. So in questions like this, or even outside of this class, we still have the same order of operations. So just remember your order of operations. All right. But good job. All right, that does actually end our slideshow here. Now we can go over the last, we have a couple more minutes in class here. We can go over the last ones. If you guys want to. All right. For this one, it was a one-pointer. What does the line mean in Java? Or operator, yes. Okay. Blank is the physical aspects of your computer, your hardware. You know, I used to ask this question 10 years ago and no one could get it right. It was really sad. But now everyone gets it right, so we're moving up in the world. People are much more computer literate nowadays. All right. Now, I don't ask you to memorize things. This is why this one was a higher point question, but you should start to remember this. How do you write your main method in Java? It's a long one. It's that magical line of code.
Oh, it's the one that we automatically just make it.
Yeah, just automatically, so, you know. I always just memorize public static void main string args. Public static void main string args. And just remember, the only one that's capitalized is the string, because he's the only class name in here. And then it is an array. Now what this means, we haven't studied methods yet, but this means that it's taking in like arguments that you can type in at the command line. So when you're executing this, you can give it some data, like a file name or a whole bunch of data when you first start your program. No, so your test is going to be, I'll show you online when I have it set up next week, but I'll open it up on Monday. It'll be like a homework assignment. You'll have a week to do it, but you only have 2.5 hours when you start it.
You can't stop
So
it
you'll have,
right?
yeah, and you can't stop it or pause it and then take the rest later. And I'll do the sample test with you in class on Monday. It will just be random questions, okay? And then they'll be very similar to these. Now, it will be inherently open book, okay? But it doesn't mean don't study, because, you know, students who don't study will not do well on a test like this still, even though it's open book. And a lot of them will have code blurbs. Hey, what's the output? And yeah, you could, you know, copy and paste the code or run it. But if you do it that way, you will run out of time. So that's why it is a timed test. Okay? So you will be given 2.5 hours. It'll be given through Blackboard. It'll be multiple choice, or true, false. Oh, yes. And then I will get the grading done pretty soon, too. I've just kind of gotten a little bit behind on grading. But as long as you've been getting your assignments in, and you know how we've been doing them in here, and I've kind of checked over your shoulder, and we've been doing pretty okay. Yeah, we'll definitely know our grades next week, okay? All right. If no further questions, then I'll upload these as PDFs, and you guys can study these. Now, you're still welcome to stay. We still have some time in class if you want to stay and work on your homework or something. You're welcome to stay and work on your homework or on other things. I don't mind. And I thought this was going to die because he kept telling me he was